Let me run unit test. Lines 233 and 234 did not get hit simply because red sensor did not return status field. The implementation of red sensor above can only return status stopped and status OK. In order to return status failed, we need to stop the red sensor function. Let me locate the dxtrace log here. To stop the red sensor function, go to stubs and locate the red sensor function. Make sure that in the stub settings, these two checkboxes are enabled. Right click to the function and create user stub. And in the stub.seed is generated, we try to print statement here. I'll copy the function signature and go to the test suite, put the function or the somewhere at the top, and revise the implementation of red sensor to return status failed. This time, let me put a printf statement here. The stub has been implemented, but it has not been registered yet. Let me rerun the unit test and see what happens. Okay, nothing has changed. But if I go to the log and locate for dxtrace, you can see that the very first call of that is stub red sensor, followed by the original implementation. Once a function is stub, the stub becomes the entry point of the original function. If we go to the stub.c that's been generated, this is now the entry point, and then it forwards the call to the original function. Now let me copy a print statement here. Since the function has been stubbed, we can also try to delete the original definition. Let me rerun unit test. Okay, so from the log, let's try to locate the X-rays. We can see that the entry point is the stub, and because there's no original implementation, it goes to the else statement. I'm referring to here. If it has existing symbol of the function, it goes through here. If you register the stub, it goes through here. It's that simple. Let me put back the reg sensor function. And this time, let me register the stub to one of the test cases. Registering will only affect to that particular test case. What I mean is, if I register in the test main loop 1 here, when the test main loop executes test case, this particular call chain for this test case will route to the stub implementation, which is what we wrote here above. Which returns status failed because we registered a stub here. For the second test main loop, since we do not register, it will call, it will enter into the stub and then go here to the original function. So there is no way that the original implementation is directly invoked. Once a function stub, all calls to that function goes to the stub. The rerouting and redirection is done inside the stub. Let me run the test case again. And now we have 100% coverage. The test main loop 1 test case return status failed to the stub implementation. The second test main loop 2, since we do not register Here, it will route to the original implementation, which returns status stop value here. So stubbing is used to alter the return behavior of an existing function or to artificially create a missing function. Red sensor is existing. However, I can call hello there, hello function. Hello is non-existent, or hello 123, something like that. And let me delete. Let me rerun this case. Okay, because hello 123 does not exist, it is a missing symbol. You go to the stubs, show view stubs stub. We can see hello 123 missing. You can right click and generate auto stub. Let's rerun again this case. And we have 100% coverage. Hello has been artificially created to our stubbing. So in summary, stubbing is to create missing functions or to alter the behavior of an existing original function.